right. Get mine out. First thing I could show you is at least you can check if your calculator, you can use your calculator to see if your graph looks right. All right, first thing we're going to graph, it's already up here, but I want to put it on your graph right now. 3 cosine x. Make sure you're in radian mode. I don't care what calculator you're using. Make sure you're in radian mode. I'm going to be using NumWorks, but graphing calculators are going to work the same way. Okay, so if I want to graph anything, I got to go over to Grapher. Make sure you're in radian mode. Okay. Add an element right here. We do have to type in the y equals. Now I noticed I figured out a little trick here today. If you're on add an element and it's shaded right like it should be right now, if you just hit enter, it'll already come up with the y equals template for you. So you don't have to type in y and then equals. So it's already there for you. So you can hit y equals, and now I got to change that to 3 cosine x. So 3 and then the cosine button, x. Okay, execute, plot graph down at the bottom. Now some of you, I don't know, does everyone have this one that looks like this one on mine or no? Okay. Yep. So here's what happens. If you look at your notes right now, I want to go from negative 2 pi to 2 pi. See how our graph on the x-axis goes from negative 2 pi to 2 pi. So this is how you can tell the calculator to go there. Everyone's got the graph up right now, correct? Okay, you can scroll up, and now it's on auto. Now scroll over to axes. You can tell you can tell your calculator what you want the axes to be from. So if you go to the axes, it says values of x, enter, and now go to minimum, negative 2 pi, negative 2 pi. We want the minimum, and the max on the x we want it to go to 2 pi. And it just gives you the decimal version of 2 pi. That's what 2 pi is, 6.2, whatever. All right, confirm. We're good. I don't need to change the y's. I just want to change the x. Confirm. And your calculator should turn into that now. Now, the only thing I don't like about the NumWorks here, it's great to use and it'll help us tremendously on the regions. The only thing that's a pain for me anyway is they don't put the pi's in on the x-axis. Like this right here, that's 2 radians. They don't do it in terms of pi. That's the only thing I don't like about it. So just a heads up there. Yep.
It's still giving me the whole
From negative 2 pi to 2 pi.
Wait, why does yours only look like that?
I don't know. What did you type in? We're only doing 3 cosine x. We're not doing the first part yet. All right. Is everyone on the same page here? Get their calculator to look like this.
For some reason, it looks like this.
Type in here. Why is it showing me? Oh, it's in your degree mode.
Oh.
So your calculator thinks they're doing degrees. That's why. Put in the radians and we should be set. Okay. Any other issues here? Max, you using your TI? Okay. Hit the window button. You know how to change? You're good there? The window and everything? Okay. Perfect. It'll do the same exact thing we're doing up here. All right. So here's 3 cosine x from your notes. Now I want you to graph this one here for part A, 3 cosine 2x. Leave the current one. All right, so just hit your back button right here. Hit back, And it'll go, leave that there, add a second element now. But now we're going to go 3 cosine 2x. And just a heads up, everyone using the numwork, see how this is in red? That's in blue. They're going to tell you what color your graph is in. That's why those colors are there. All right, once you have that, go to plot graph and take a look now, huh? So my red one was the original. Now I got a blue one. Now take a look. With my red one, the original one, 3 cosine x, my original one here, how many cosine curves do I see here? How many cosine curves from 0 to 2 pi do I see here? The red one, it's the red one I'm talking about. How many cosine curves do I see? Oh, just the red one. Remember what a cosine curve looks like? Oh, do we remember what a cosine curve looks like? Yeah, how many do I see here?
1. What?
The red one?
What?
From 0 to 2 pi. I'm not looking at the full crap. 0 to 2 pi. Just 1. But now, when I put the new one in, 2x, how many curves do you see now from 0 to 2 pi? 2. So you're telling me when I put a number in front of the x, it affects how many curves I see. And also, take a look. Go back at your calculator. How long did it take me to make this red curve? How long? From 0 to what? To 2 pi. But now when I put the 2 in front, take a look. Stop right there. Did it take me 2 pi to make a full cosine curve when I put a 2 in front? No, it took me half as less time. See the difference? When I put a 2 in front, it only took me half the time to make a curve. All right, one more. Go back to your graph. You're going to add a third one in now. Take a look at your notes. Now we're doing, instead of a 2, we're going to do a 1/2. So 3 cosine 1 divided by, make sure that x is out of there, please. Make sure it's up to the side. So it looks like this. Okay. So this one's going to show up in green. So everyone, I want you to look at the green curve. The green curve now, when you graph it. Do you guys have colors or no? Or is it just me? Okay, all right, whatever color. Make sure you identify the color. We're off on colors. Mine's going to be green. Know what color yours is going to be. Take a look at it. Just look at the positive side. Look at your curve you just graphed. Do you see a full cosine curve? You only see how much of it? Oh, interesting. You only see half of it? Because what number did you just type in with it? 1/2. And it's going to take me a little bit more than 2 pi to make the full curve. All right. So what I'm just trying to show you here on your graph is, 1, how to graph and how to use it. 2 is, all right, when I graphed 3 cosine 2x, how many full cycles did we see? 2 cycles. What's going on? Okay, we saw 2 cycles when I put the 2 in front. When I put the 1/2 in front, how many cycles did I see? I only saw a 1/2 of a cycle. So today what we're going to do, hey, I put a number in front of x. It's going to affect how many curves I see and how long it takes to make a full one. So let's just get right to the meat of it here. And I don't need you to copy this down. I just need you to focus it up here now. What's that number mean again? Yesterday. What's that number? That's midline. Also my what? Midline / what else do I refer to it as? Shift, right? Okay. We have a number out in front here. That gets us to our min and max, right? That got us to our min and max. And now let me introduce what this next number is going to be in the middle with the x. This number here is called my b value. That's going to be your frequency. Okay, that's called my frequency, that b value. I make sure we understand all three. Min and max for the a value, my shift for the c, and now this b value I'm going to introduce today is called the frequency. All right, called the frequency. All right, let's jump right into it now. You're going to help me out. Three cosine x, what's the number next to the x? 1. So we say the frequency here for that first curve is 1. Period. Let me go back. Don't touch your calculators. That's my red curve here. How long did it take me to make one full curve here? How long did it take me? All the way to 2 pi. All right, so for that one, the period is 2 pi. And I think it's going to be easier if I just show these one at a time now. So let me get rid of this one. Clear that out. Clear that out. Next one, part B. What's my frequency? What's that number in place of B now? A 2. A 2. Yep. All right, you guys help me out now. Period. I know you can't tell because it's not in terms of pi, but everyone agrees from here to this point right here, I make one full sine curve. Well, that was 2 pi down here. This is half of it. So what do you think? How long? Pi. Correct. So it's going to take me pi. So it looks like as the number increases, the time it takes to make a curve decreases. Let's try one more. What's my frequency here? 1/2. All right, let's look at the period, how long it takes. Let me get this bad boy out of here. And it'll go a lot quicker. This is me trying to use this. 3 cosine 1/2 x. Just look at this side. You see a full curve? So if I extended it, this is 2 pi. If I extended it out, how long do you think it would take to make a full one? Because right now we're at 2 pi and we see half of it. So what do you think? At 4 pi. Good. So the period here, 4 pi. So you see as the frequency goes down, it takes me longer to make it. As the frequency increases, it takes me less time to make a full curve. Richie?
I'm confused about how you put it in terms of pi.
What do you mean?
On the
Okay, here you go. Ready? You see this? See how this ends at like 6 and a little bit more than 6, right? Two pi. The problem is, and this is what I was talking about earlier, the problem with this calculator is it doesn't put the x-axis in terms of pi. Like it just goes 6.283, and that's where the curve ended. All right, so you're not seeing the pi because your calculator doesn't put it there.
How are we supposed to know what it is?
Oh, you'll let me keep teaching. We'll be fine. All right, let me keep teaching here. All right, so from here, and this is probably an answer to your question right away, Richie, is you're right. How can I look at my numworks calculator and know that's 4 pi or know that that's pi? That's your question, right? Okay, I'm going to have a formula for you. All right, this is how we're going to find period every time. If you want to know the period of any curve that we move on for the next couple days, here's the formula. So what do you have? A formula to find A, right? What's the formula to find A again? Max minus min over 2. C is max plus min over 2. Now, if you want the period, 2 pi divided by that B value, frequency. Okay? We want frequency. Okay, so 2 pi divided by the frequency. That's how we find the period. So there's your answer, Richie. I don't need to look at a graph anymore. I wouldn't expect you to. I want you to use the formula. And where do I get the b value from? That's right in the equation. You can plug that right off. All right, get ready. I'm going to start calling on numbers here. What's the period of each? What's the period of each here? So 6 sine 4x. What is the period? How long it will take on the x-axis to make it? I don't want you to look at your graph either. I want you to use the darn formula, which I just gave you. P equals 2 pi over b. I need you to be able to pluck the b because there's a 6 and a 4 up there. One's the b value, one's not. All right, here we go. My cheat sheet. Okay, let's roll 1, 3 here. Richie, there you go. Back to you now. What's my b value? 2 pi over 4. I will certainly accept that. Don't give me a decimal. Don't give me a decimal version. Or pi over 2. Yeah, but leave the pi there, please. Okay, leave the pi. So 2 pi over 4 or pi over 2, I would certainly accept. All right, but don't give me whatever pi divided by 2 is as a decimal. Everyone all right? 6 is the a value. That's what it goes up and down to. All right, next one. We're going to have to do a little work. Actually, we're not. You just plug the darn thing in your calculator. 2 pi over, what's my b value here now? Where am I going here? Ethan, what's my b value? So 2 pi divided by pi over 3. This I will not accept. All right, that's not in simplest form, but if you plug it in your calculator, it'll give you simplest form. Do you have that, Ethan?
Yeah, I got 6.
Just 6, yep. 6 radians. Remember, just 6 radians it'll take. We have questions about putting it in the calculator, or I don't care if you're using TI or NumWorks, you can still do it. Just getting a fraction template up if you're using the TI. And then what about part C? 2 pi over, what's your b value here? Oh, Ethan again, what do you got? 2/3, right? I don't put the x with it. Two pi divided by 2/3. Final period here. 1, 3. Richie, back to you. 3 pi. Yep. Question finding the period, because now we're getting hardcore. Buckle up. Graphing now. This is about as tough as I can get right now. Because now, when you have a b value that's not 1, and I should have changed this, but these aren't your numbers anymore. Pi over 2, pi, 3 pi over 2, and 2 pi are no longer valid. Okay, because it's not going to take us to 2 pi anymore to make this curve. It's going to take us less or more. So let's first describe min, max. Something that you guys are capable of doing right now. Setting up the y-axis. What is the min and max of this curve? No shift to worry about, right? No shift. So what's my min and max of this curve just looking at it right now? Min and max. Nothing else. Nothing else. Emma, what's my min and max?
-1 and 1.
Okay, other than the people telling you in your group.
She wasn't here yesterday.
Okay, isn't this, I threw something, I threw a number in front. Yesterday was the shift. It says nothing to do with shifting. What's my a value, number out in front?
1.
That tells us the increase, or that tells us the min and the max. Unless I have a shift, but I don't here. All right, so you got your y-axis taken care of. Now let me go over the rest now. X-axis. Because again, if you guys see that, if you have a frequency other than 1, it's not going to be pi over 2, pi, 3 pi over 2, and 2 pi like we're used to the last 2 days. It's going to be something different. First thing you need to find is, what's the period? How long will it take me to finish this curve? That's the formula we just went over. 2 pi over, going back to you guys, what's my b value? Richie should be a pro at this.
2 pi over 1/2.
1/2. Yep. Everyone go ahead, calculate the period now. 2, okay, 4 pi. All our graphs for the last 2 days have always ended where? 2 pi. Not anymore. This is going to end at 4 pi. But I still need to break it up evenly. And when I say break it up evenly, does anybody remember how many parts I had? 1, 2, 3, 4 equal parts. So I need to break this up into 4 equal parts right now. And it can't be pi over 2 pi. It's going to end at 4 pi. So you better have that last tick mark be 4 pi, because that's where my curve's going to end, at the period. All right, what about the other tick marks? Here we go. This is what I'm going to call key values. And it's going to make sense very quickly. How many equal sections are you breaking it up into? Every time 4. Every time you're breaking it up into 4. So I'm going to take that period you found, how long it takes total, and divide it by 4. So every time I hit a tick mark on the x-axis, it's going to be pi. I'm going to add pi every time. So the first one is going to be pi. How do I find the second one? Keep adding pi. Next one, 2 pi. Next one. Oh, and then look, when you add pi again, where do you magically end up? At the period, 4 pi, where I should. That's all the new stuff, is changing your x-axis. And now from here, what I want you to do, graph a little cosine for me. The rules aren't changing. Rules don't change. Don't be nervous and scared. Who's up? Need a stud here. 4? Okay, Marty, I'll take it. All right, just joking. You ready?
For what?
Don't get nervous. Tell me how to graph cosine. Where does cosine start?
1. Wait.
In this,
negative 1.
oh, in general, where does every cosine curve start?
Doesn't it start at 1?
This one will,
Yeah.
but I want to say the max. That's what I want to say, max.
Oh.
Max, right? So this one will start at 1.
Oh,
Yes,
okay.
you're correct. So it'll start at 1. Where does it go from there?
0.
Not yet.
Back to the x.
Goes to the 0. Where in this, usually we say midline. But why don't I have to worry about that? There's no shift here, right? So we are going to go back to 0. There is no shift. Keep talking. Max, midline, then where?
The minimum?
Minimum, yep.
Negative 1.
Guys, look, I'm still graphing the same darn things except that new points on the x-axis. Nothing's been changing. You see that, Grant? Darn right you do. Keep going, Marty.
Back to the midline.
Yep. And then where does every cosine curve end?
At 4 pi. Well,
On the y-axis.
yeah.
Where?
At 1.
At the max, which in this case is 1. Guys, I'm still graphing the same points, just the x-axis looks different. One doesn't make you great, but questions here. All right, here we go. Now this is what you can get used to, a blank slate, where you draw in your own x and y axes. Okay, so let's get those down first. Draw them in yourself. And we're only going to be worried about 0 to 2 pi, so there's no reason to do that. All right, I don't need that. We can just go right from here to here. And I'm going to have you guys, by the end of tomorrow's class, you're going to be like machines doing this. Find your y-axis first. Do your y-axis first. Is there any shift here? Nope, none to worry about until tomorrow. How high and how low is this going to go? 1 to negative 1. I'll put some shifts in there tomorrow to make you nervous. So it's up. Hey, you want to do that and that? That's fine. I'm a big spreader out guy. All right, so it doesn't look very, very tiny. That's up to you, though. 1, 2, 3, 4. 1, 2, 3, 4. Just make sure the same interval there. I just like to spread it out. All right, ready for the new x-axis. You can put your tick marks in. You know you're going to have 4, right? You can put them in, space them out. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Just make sure they're separated by the same interval. You want to go by threes? I don't care. All right, now we got to figure out what they are. What labels do I put there? First step in doing that is, how long is it going to take to make this curve? That's our period. 2 pi over, what's your b value here? Ooh, Ethan. B value? Okay, yeah, everyone go ahead. Calculate the period. What do you got, Drew?
8.
8. Now remember, that's not 8 units. That's 8 radians, and that is where my graph's going to end every time. There's it. There's where it's going to end. Now I got to cut it up into how many equal parts? 4 equal parts. Yep. So I'm just going to start abbreviating key values, KV. Take your 8, divide it up into 4 equal parts. So each tick mark I'm going to go by 2's. Remember, we're still talking radians. I'm just not going to put a pi with it. Just 2 radians. So 2. What do you got for me next? 4, 6, and by the time you add your last one, it should be back at the end. And now we're going to do a sine curve here for me. Sine curve. All right, talk sine with me. Kate, here we go. Where's the sine start? Yep, there is none. Well, there is one, but it's 0 since there's no shift. Next. Yep, up to the max.
And then back to,
Yep.
and then down to the minimum. And then back to.
Yeah, guys, I'm not doing anything. You're signing. So now you guys realize why I was so going nuts the first day, saying you got to know the rules for sine and cosine and where it goes. That's why. And I don't have any others. Okay, go to number 3 on your assignment then. Go to number 3. Just a little change up. See how many studs I got in the room. I know I have a lot. Which way you want to take it first? There we go. Thank you, guys. Thank you. Okay, let's see how many studs we got in the room. If you guys that weren't here the last couple of days, don't worry. That doesn't mean a sine curve. That just means a curve that repeats. Sinusoidal. It's funny to say, right? What did I give you in this one, though? I'm giving you the period and asking for the frequency. What's the formula? 2 pi over b. But now, where's that 18 going?
Where B is.
What's the 18?
Where pi is.
Whoa, whoa.
What?
If the period is equal to 18. So where do I put the 18? Oh, boy, guys. B represents what?
I said P.
I know, but I have people saying the letter B right now.
I said P.
Are we all? It goes in for P. That's the period. It goes in for P. And now what am I asking you to solve for? The frequency, which is B, as in boy. How do you solve that? How do we solve this? Does that help you if I put the 18 over 1? I can cross multiply here. So 18b equals 2 pi. One more step to solve for b. Divide by 18, yep. You can leave the pi in your answer. So what's my frequency here? Pi over 9. So I can ask for frequency, yep.
Can you just plug it in, like with the, like I did 2 pi and then I did pi over 9, and that's how I knew, because it equaled 18.
Yeah, you can see what it is here. Absolutely. All right, go. Let's go. Get to the rest. Get to the rest, please. Some of these should go pretty quick here.